There's one programming language that's very useful to both programmers and non-programmers alike, and that language is SQL. So what is SQL or SQL? Well, it's short for Structured Query Language, and it's the language you use to interact with databases. So for example, if you had a database that contains a business's customers, then you would use SQL to create the customer records, read the customer records, update the customer records, and delete the customer records. Now, there are other things you can do to a database with SQL, but in this video, we're going to focus on what I think is the most important thing for a SQL newbie. So what are we going to be focused on in this video? Well, the most common thing performed with databases is reading or viewing the data, and that's what we'll primarily focus on in this video. Okay, before we dive in, you might be wondering, is SQL something you really need to know? In other words, should you take the time to watch this video and begin learning SQL? Well, if you're a programmer, there's a really good chance you'll need to know SQL, but what if you're not a programmer? Should you learn SQL? Well, if you learn SQL, then you'll be able to answer many, if not most of the questions you have about your business. In fact, to the non-programmer, knowing SQL is kind of like having a superpower that sets you apart from your peers. So if you're a curious person and you want to be able to definitively answer questions that arise at your place of work, then I strongly recommend you learn SQL. And just so you know, learning SQL isn't that hard. Okay, so SQL is how you interact with databases, but some of you might not know exactly what a database is. So let's answer the question, what is a database? Well, a database is kind of like a digital filing cabinet, where we store, organize, and retrieve information. Now, within a physical filing cabinet, there are usually folders for collecting different types of documents, such as orders, invoices, payments, and so on. And typically, the folders and the documents within the folders are stored in an orderly way so that the documents can be quickly accessed when needed. Well, databases are sort of like filing cabinets, but databases don't have folders per se. They have tables for storing similar records. We'll learn more about tables in just a moment here. So, as a beginner, you can think of a database as kind of like a digital filing cabinet. Now, there are different types of databases, but what we'll be focusing on is relational databases, which are by far the most popular type of database. Okay, so which particular database are we going to use in this video? Well, there are many choices, but what you should know is the SQL you'll be learning in this video is applicable to all of these databases and many more. So honestly, we could use any of these databases in this video, but we've got to pick one, and the one I picked is SQLite. So why SQLite? Well, because it has a lot of features and it's easy to use. Now, don't let the light in SQLite mislead you. SQLite isn't a, quote, light database, and it isn't for small or toy-like scenarios. SQLite is the most widely used database in the world, and it's used in both small applications and large applications. Odds are you use SQLite every day in many different places. For example, SQLite is the most widely used database for smartphone applications, and it's used in web browsers, and operating systems, and desktop applications, and the list goes on and on. So how do you use SQLite? Well, in a moment here, I'm going to have you download an example database file, which we'll use throughout the remainder of this video. But we need more than just a database. We also need an application to run queries in. Now, there are many applications you could use to run database queries, but in this video, we'll be using DBeaver, which is free and it supports a bunch of different databases, so it's software you can most likely use with your own database as well. You can install DBeaver by navigating to dbeaver.io, then click Download, and then follow the instructions for your operating system. The next thing I want you to download is the example database that we'll be using in this video. To download the database, open your web browser and navigate to the URL bit.ly/bikesdb. This should download a file named bikes.db, which is the SQLite database we'll be using throughout this video. The next thing we'll do is run DBeaver, the graphical query tool we installed a moment ago. Then we'll click the plug icon here, which will open a wizard that will walk us through the process of connecting to our database. So in the wizard, click the SQLite icon and press the Next button. Now click the Open button, then navigate to the Downloads folder and click the bikes.db file we downloaded just a moment ago. And finally, click the Finish button. Okay, at this point you should see an icon for the Bikes database here in the upper left corner of the screen. Alright, so what's in this Bikes database? Well, if I expand the Bikes database inside DBeaver, you'll probably get a pop-up window like this, prompting you to download the driver files for SQLite. Go ahead and click the Download button. After the database driver has been downloaded, you should see a series of folders, tables, views, indexes, and so on. In this video, we'll be focused on tables, so let me expand the tables, and as you can see, there are 4 tables in this database. Okay, but you might be wondering, what's a table? Well, you remember when I said databases are kind of like digital filing cabinets? Well, tables are sort of like the folders in a filing cabinet. Tables store similar information. So in our database, we've got a table called customers, and as the name suggests, it stores the important customer information for a fictitious bike company. So let's take a peek at what's in this customers table. So I'll right-click on the customers table, then I'll click View Table, then I'll click the Data tab here, and now we can see the data in this table. So as you can see, a table is really a grid, kind of like a spreadsheet with columns and rows. Each column represents an attribute of a customer, and each row represents a complete customer record. So for example, this first row represents the customer named Chris Green, and here's Chris's email and phone and address and so on. Now you might be wondering, what's this customer ID column? Well, it's a good practice that each row or record in a table should have one or more columns that are unique within the dataset. And in this table, this customer ID represents a unique value for each customer. It's what's called a primary key, and again, its value uniquely represents or identifies each row. In other words, customer ID 1 is unique in this column, and it's Chris Green's customer number. We'll be using this customer ID a few different times in this video, and as you'll see, it's an important column for writing several different kinds of queries. Alright, let's write our first SQL query. So first I'll close this view of the customers table. Next I'll click the SQL button in the toolbar, which opens up a new window where we can write SQL queries. Okay, so here's what I want to do. I want to get a list of all the customer names, and to do this I'll write what's called a select query. So I'll say select, and now we need to write the column we're interested in seeing, which begs the question, what columns are in the customers table? Well, we can see all the columns by expanding the customers table. Then we'll expand the columns, and here's a list of the columns we can query for. In our case, we want the name, so I'll type name. Next, I'll type the from keyword, followed by the table name we're wanting to query, which is customers. Okay, this is a valid SQL query, and we can run this query by clicking this button here, or we could press the shortcut, which is Control-Enter on the keyboard, and after running this query, we see a list of the customer names. Cool. Now, let's say we'd like to also see the customer's email address. So how do we modify this query to include the email? Well, we can simply put a comma after the name column, and then we can type email. And now if I run this query again, we see both the customer's name and their email address. And we could add even more columns here if desired. But what if we wanted to view all the columns in this table? Do we have to write every single column name right here? Well, you could, but there's a wildcard character we can use, the asterisk, or what is commonly referred to as star, which we can place after the select keyword. And this asterisk basically means return all the columns from the tables being queried. So let's use the asterisk and run this query, and as you can see, all the columns were returned in our result. Nice. Let's run a query on another table, the orders table. So I'll say select star from orders, and I'll execute this query by pressing Control-Enter. Okay, so we see 4 columns in the results. Do you have any idea what this order ID column is? Well, it's the primary key for the orders table. In other words, the values in this column uniquely identify each row. What about this customer ID? Any thoughts on what this is? Well, it's a reference to the customers table. In other words, it's related to the customers table, but we'll take a closer look at this in a few moments. The next column is the order date, which is self-explanatory. And lastly, we see the status column. Now, we see a few different values in this status column: completed, pending, and so on. What if we wanted to determine all the different statuses used in this column? Is there a SQL query that would tell us the distinct list of statuses? Yes, there is, and it's pretty intuitive. Here's how we would write this query. I'll say select status from orders, but this doesn't quite give us what we want. Running this gives us every order status, but we can modify this query by using the distinct keyword before the column name, and running this query gives us the inclusive list of all the statuses used in this table across all the rows. What do you think would happen if I added the order date to this query? Let's try it and see. So I'll add the order date column, and I'll run the query, and now what we see is the distinct combination of status and order dates. Now you'll notice that the rows are in no particular sequence. For example, the dates are all out of sequence, but let's modify this query so that the results are sorted by the order date. To do this, I'll modify the query by adding order by order date onto the end of the query, and I'll execute this query by pressing Control-Enter. Okay, now we see the results are ordered by the order date in ascending order, and we can see that on January the 10th, the only statuses used were completed, but if we look a few rows down, we see that on February 20th, there were 2 statuses used, completed and pending. Alright, I want to get back to the customers table, so I'll say select star from customers, and I'll execute this query by pressing Ctrl Enter. Okay, what if we wanted to look at just the customers in the state of Washington? How could we write a query to answer this question? Well, to fetch the customers from Washington, I'll add a where clause to this query, and I'll say where the state equals WA, the state code for Washington, and I'll execute this query, and as you can see, we've got 3 customers from Washington. Okay, well, what if I wanted to modify this query to include customers from both Washington and Texas? Any guesses on how I might answer this question? Well, the nice thing about SQL is that it's pretty intuitive, so it's relatively easy to learn. Let me show you what I mean by intuitive. So to get the list of customers from either Washington or Texas, I'll say state is WA or the state is TX. Now I'll run this modified query and we see 4 additional customers that are from Texas. What if we wanted to include Ohio as well? Well, you could just type or the state equals OH, and running this query shows us 1 additional customer from the state of Ohio. Okay, now this query is getting a bit verbose and it's starting to become a bit hard to read. So what can we do to make this query a bit more readable? Well, first of all, we can break this query up into multiple lines. So I'll put the list of columns on its own line, then the from table clause on its own line, and lastly I'll put the where clause on its own line. Now there's one other thing we can do to make this query a bit more readable. Let me show you. First I'll comment out this line here by adding 2 hyphens. When you use hyphens like this, you're basically telling the database to ignore any text that comes after these hyphen characters on that line. Now I'll rewrite the where clause to say where the state is in the following list, WA, TX, or OH. Now I'll execute this query, and as we can see, we got the same exact result, and I think this where clause is easier to read and understand at a glance when compared to this original where clause. Okay, there's something else that I want to point out, which is the format in which I've been writing these queries. You may have noticed that the SQL keywords I'm using in this query are all capitalized. Now, technically, this isn't required. You could type this in lowercase or mixed case. However, the convention is to capitalize them, as it slightly improves the readability of the query, so I suggest following this convention. Okay, what if I wanted to query for all customers not in these 3 states? Well, you could modify the where clause to say the state is not in Washington, Texas, and Ohio. And running this query gives us all the customers that are in states other than Washington, Texas, and Ohio. Okay, but what if we wanted to write the same query using a syntax more like this line here? Well, we need to make 2 changes. First, we need to change the equal sign to the not equal sign, which you can do by placing an exclamation point in front of the equal sign. And lastly, we need to change the or logical operator to the and logical operator. So now we're saying the state should not be Washington, and it should not be Texas, and it should not be Ohio, and running this query gives us the same result. Okay, the next thing I want to query for is all the customers with the first name of Sam. So to accomplish this, I'll modify the where clause to say the name equals Sam, but do you think this will work? Well, let me draw your attention to this row right here, and I'll ask you again, do you think this query here will show me this row? Nope, it won't, because right here in the query, it's saying only show me customers where the name is exactly Sam, which isn't the case for this record. So is there anything we can do to our query to make it return this row and other similar rows where the first name is Sam? Yep, we can change the operator from the equal sign to the like operator, and then we can modify the name Sam to include a wildcard character after the M, so I'll add a %, which is a SQL wildcard character. So basically, this statement here says, show me all the customers where the name starts with Sam, and it can have anything after the letter M. Okay, I'll run this query, and as you can see, there are 3 customers with the first name of Sam. Nice. Now you should know there are other wildcard characters you can use with the like operator. The most common other wildcard is the underscore. So if I write a query like this, then the filter would match any single character at the start of the name, followed by an A and an M, and then anything can come after the M. So I'll run this query, and as you can see, the query picked up 1 additional customer record, Jamie, and if there were customers named Pam and Cam and so on, it would pick up those records as well. What if we wanted just the customers with the first name of Sam that are in the state of Washington? Any thoughts on how to answer this question? Well, we can type the AND logical operator, then I'll say the state should be Washington, and now I'll run this query, and as you can see, there is 1 customer named Sam in the state of Washington. What if we wanted to modify this query to include customers named Sam in Washington or California? Well, we could add an or state equals California onto the end of this query, but do you think this will work as intended? In other words, do you think this will return all customers named Sam from either the state of California or Washington? Let's try it out and see. Okay, well, we see some customers who aren't named Sam, so obviously something isn't quite right in our query. So what's going on here? Well, you have to understand the precedence of these operators. The AND operator has a higher precedence than the OR operator, so this means that the filter name like Sam and state equals Washington is evaluated as one condition, and the result of this is combined with the OR state equals California condition. So this Sam in our result is from Washington, and the other rows are customers from California. Okay, but what I really wanted was the people named Sam in the state of California or people named Sam in Washington. So how do we fix our query to achieve this desired result? Well, we can put parentheses around this part of the statement to group the OR clauses together, similar to what you might do in a basic math problem to set the proper order of precedence. So now if I run the query, we see two customers named Sam, one from California and one from Washington, which is the result we were looking for. Let's shift over to the products table. So here we see the 5 columns in the products table, and let me ask you this. How do you think we should modify this query to only show products with a price of more than $1,100? Well, I bet many of you can answer this question on your own just by guessing, because as I said earlier, SQL is pretty intuitive. So go ahead and pause this video and try to modify this query to only show products that have a price of more than $1,100. Okay, let me show you how to write this query. I'll say select star from products where the price is greater than $1,100. Now I'll run this query, and as you can see, our list of products only includes items that have a price greater than $1,100. What if we wanted to show products that are greater than or equal to $1,100? Well, we can just change the greater than operator to be the greater than or equal to operator. And running this query includes products that are $1,100 or more. What if we wanted the list of products to have a price from $1,100 to $2,000? Well, we can modify this query by adding the AND logical operator. Then we can say price is less than or equal to $2,000. Now I'll execute this query, and as you can see, it worked. There is another way of running this query by using the between operator. Let me show you. So I'll say the price must be between $1,100 and $2,000, and running this query gives us the same result. Okay, I want to head back over to the orders table again. Earlier, I pointed out this customer ID column, and I want to ask you again, what exactly is this column? Well, it's a reference to the customer ID field in the customers table. So for example, when you see this customer ID of 24, what this means is the customer who placed this order is the customer with customer ID 24 in the customers table. In other words, there's a relationship between the orders table and the customers table. So let me ask you this. Why not just include all the customer information in the orders table? In other words, why not just have the name, email, and other customer fields in the orders table? Well, for a few reasons. If you include all the customer information in the orders table, you'll have a lot of redundant data, which results in increased storage. But by storing each piece of information in just one place, the customers table, we reduce the total storage space required, and it ensures that updates, deletions, and insertions can be made in a single location, thus reducing the potential for data inconsistencies. Okay, but what if we truly need to see the orders, as you see here, but with the customer name in the result as well? Is there a way to write a query that gives us information from multiple tables? Yes, there is, and it's accomplished by using what's called a table join. Let me show you. So I'm going to modify this query by saying from orders, inner join customers, and now we need to tell the database how to join these two tables. And the way we do this is by saying on customers.customerID equals orders.customerID. Alright, so this last part here tells the database how these two tables are related. They're related by the common customer ID column found in each table. Now if I run this query, we see all the columns from both the orders table and the associated columns in the customers table. Okay, so how do we modify this query to include all the columns in the orders table, but only the name column in the customers table? Well, we can do the following. After the select keyword, I'll add orders.star, which basically means show us all the columns from the orders table, and then I'll add a comma, and I'll include the name column. Now I'll run this query, and we get the result I was looking for. Okay, but what if we wanted to include all customers in the query, even if they don't have any orders? Well, we can modify this query from an inner join to what's called a right outer join. So the inner join basically means give me only the customers that have orders, whereas a right outer join means give me all the records from the table on the right, the customer tables in this case, and only give me the order records that have a corresponding customer record. If I run this query, we see a bunch of rows that include both the orders and the name, and then further down in the results set, we see some customer names without values in the orders column. So basically, these customers here have never actually placed an order. Now there's also a left outer join that works similar to the right outer join, except it includes all records from the table on the left. In other words, it's just reversing the table to include all the records for. Okay, what you should know is that the vast majority of the time you're writing SQL queries with joins, you'll be using inner joins. In fact, the inner join is so common that you can actually drop the inner keyword and just use join, but it still runs as an inner join. Alright, I want you to look at this query and I'll ask you, do you think this query will work? Well, if you look at the query, it actually looks valid at first glance. But let's try and see. And it didn't work, and if we look closely at the response, we see that it's complaining about the column named customer ID, and it says it's ambiguous. So what's going on here? Well, the problem is that the customer ID column exists in both the orders table and the customers table, so the database is confused and doesn't know which column to give you in the result. Okay, do you have any thoughts on how we could fix this? In other words, is there a way we can be a bit more explicit about which customer ID column we're wanting? Yes, there is. All we need to do to fix this query is qualify the customer ID column by adding the appropriate table name in front of the column. So to fix this query, I'll prefix the customer ID column with the table name, orders, dot, and I'll run the query again, and we see the result we were looking for. So by adding the table name before the column name, we eliminated the ambiguity, and the database was able to execute the query. Now we're going to start talking about functions in SQL. So what are functions? Well, probably the easiest way of introducing functions is to show you a simple example. So what if you wanted to know the total number of customers in the customers table? How could you find the answer to this question? Well, in a small database like the bikes database we're using, you could just select star from customers and then scroll down to the bottom of the list. But for non-trivial databases, this won't work because there could be hundreds of thousands or millions of customers. So what's a better way of figuring out the number of customers? Well, this is where functions come into play. So there's a function called count, and here's how you can use the count function. So I'll say select count, and then in parentheses I'll key the asterisk, followed by a closing parentheses from the customers table. And if we run this, we see that there are 24 customer records. Now you should know that we can still modify this query like we did earlier. For example, I can say where state equals Texas, and if I run this query, we see that there are 4 customers from Texas. Now the count function is just one of many functions available to you, and we're going to look at some of the most commonly used functions right now. So here's a question we'll try and answer. What is the total sales amount of all orders? To answer this question, we need to look at the order lines table. So let's look at each column in this table before we try and calculate the total sales amount. Okay, the first column we see is the order line ID column. This column is the primary key for this table. The next column we see is the order ID column. Do you have any thoughts on what the values in this column are for? Well, it's the column that establishes a relationship between this table, the order lines table, and the orders table. There's a name for this type of column. It's called a foreign key, and it points to the primary key in another table. And similarly, the products ID is a foreign key column that relates to this table, the products table. We'll be using these two columns a bit later when we write some joins to the associated tables. The next column we see is the quantity column, and the final column is the price for the product being ordered. So how do we figure out the total sales dollars in this table? Well, this is where the sum function comes in handy. So to calculate the total dollars, I'll write the following query. Select sum, and then in parentheses I'll include the price column from the order lines table. So this query will work. In other words, it's going to add together all the price column values and show us the result. But does this give us the total price? Well, it doesn't, because the prices shown here are the individual prices, and some of these order lines have a quantity greater than 1. So to fix this, I'm going to do a little bit of math in the sum function. So instead of just summing the price, I'm going to sum the result of multiplying the quantity times the price. And now I'll run this query and we see the result here. Okay, what if we wanted to modify this query so that we only see the sales totals for the state of California? Do you have any thoughts on how to answer this question? Well, we're going to have to do a join to the customers table, which is where the state values are. Then we'll need to add a where clause. But let's take a quick look at the order lines table again, so we can figure out how to join to the customers table. Okay, so how do we write a join query from this table to the customers table? Well, I'll give you a hint. We can't do the join directly. We have to do it indirectly. In other words, we can't join the customers table from the order lines table because we need to have the customer ID in this table. But what we can do is join the order lines table to the orders table, and then we could join the orders table to the customers table. Let me show you how this is done. So I'll say order lines join orders on the orders.orderID equals the orderlines.orderID. And if we run this query, we see the order lines columns and the order columns. And now we've got the customer ID column, which we need to join to the customers table. So I'll modify this query even further by saying join customers on customer.customerID equals orders.customerID. Now, if we run this query, we see the columns from all three tables, and most importantly, we now see the state column, which means we can write a where clause to filter for orders in the state of California. So let me modify the query by adding a where clause that says the state should be equal to California. And if we run this query, we only see the rows from California sales, so we're getting closer to our answer. There's one more filter we should probably add to this query. What I'm referring to is the order status field. If we want a sales total, we should probably look at the completed orders. So I'll add on to our where clause and say the state is California and the status is completed. Okay, now all we need to do to get our sales total is call our sum function. So instead of selecting star, I'll say select sum, then inside the parentheses I'll say quantity times the price, and if I run this query we see the sum total here. Cool. Alright, I want to modify this query a little bit so that instead of just showing us the sales from one state, it shows us the summarized sales for all states. So how do I accomplish this? Well, first, I'll get rid of the filter for the state equaling California, then I'll do two things. First, I'll add the state to the select clause, and lastly, at the very end of this query, I'll say group by state. So in this modified query, we're saying, don't show me the total sales, show me the sales grouped by each state, and since we've included the state in the select clause, we'll also see the state in the results. Okay, I'll run this query, and we see the results we were looking for. Cool. Alright, let's run a simple query on the products table. So I'll say select star from products. The next question I want to answer is, what is the average price of the products in the Spikes database? Well, to answer this question, you can run the average function. Let me show you. Instead of selecting star, I'll select average price, then I'll execute this query, and there's our answer. Next, I want to calculate the minimum and maximum prices of the products. To do this, I'll use the min and max functions, and instead of calculating them individually, I'll just add these function calls to this query. So I'll say min price, comma max price, and then I'll execute the query, and as you can see, we get the results we were looking for. Now there's one thing I don't really like about this query, and that's the column names shown here. I want to use some custom column names here in place of what we're seeing right now. So how do I give these columns unique names? Well, you do what's called aliasing, and here's how you do it. First, after the average function call, I'll say as average price. Then after the min function call, I'll say as min price. And lastly, after the max function call, I'll say as max price. Then I'll execute the query and take a look at our column names. They reflect the aliases we used in the query. Okay, now if you truly want to learn SQL, you need to get your hands dirty. What I mean is, you've got to actually start writing queries on your own. So to help you learn, I've got a few challenges I'm going to give you. So I'm going to ask you a series of questions about the data in this database, then I'll ask you to pause the video after each question, and you should try and write a query to answer the question. After you're done writing the query, hit play again and I'll show you the query I wrote to answer the question, and I'll introduce some new topics as well. Okay, here's the first question. Calculate the number of customers in each state and sort the results by the state. So your results should look something like this. Go ahead and pause this video and try writing a query to answer this question. Okay, here's the query I wrote to answer this question. Select state, comma, count star as customer count from the customers table, and then I group the result by state, and I order the result by state. Now, what if we wanted to sort the states in descending order? How do we do that? Well, the default sort order is ascending, but to make it sort in descending order, we simply add the DESC keyword after the state. And if I execute this query, we see the states are sorted in descending order. What if we wanted to sort these results by customer count? How would we do this? Well, I'll just replace the state in the order by clause with the count star, and as you can see, it worked. Here's another question. What if you wanted to filter these results to only show states with 3 or more customers? How would you write a query to do this? Well, you might be tempted to try and add a where clause to this query. Maybe something like this, where count star is greater than or equal to 3, but if you try and execute this query, you get an error that says you're misusing the aggregate function. You see, you can't use aggregate functions like count in the where clause because of the order of operations in SQL query processing, but you can filter an aggregate function result in a new clause called a having clause. Let me show you. First, I'll get rid of this invalid where clause. Then after the group by clause, I'll say having count star greater than or equal to 3. Okay, on to the next challenge question. First, let's look at the products table, and here's what I want you to calculate. What is the total dollars of on-hand inventory for products that are not bikes? Go ahead and pause this video and try to write the query to answer this question. Okay, here's how I solved this problem. I said select the sum of the price times the stock quantity, which I aliased as bike inventory, from the products table where the name is not like %bike. The trick here is that all the products that are bikes end in the word bike. So I used a wildcard, the %sign, followed by the word bike. So basically what this means is the product name must not end in bike. And here's the result. The next challenge is for you to figure out the top 5 products by on-hand inventory. In other words, figure out the top 5 bikes in terms of on-hand inventory dollars. So your results should look something like this. Go ahead and pause this video and try and answer this question. Okay, here's my solution. I said select name, then price times stock quantity from products, and then I ordered by the price times the stock quantity in descending order. Now when I execute this query, we see all the products sorted by on-hand dollar amount. And this query gives us the answer we're looking for, but there is one little tweak we can make to this query that gives us an even more precise answer. So what's the tweak I'm talking about? Well, we can use a new clause called limit. So at the very end of our query, I can say limit 5, which means only return the top 5 results. And if I run this query, we get the exact answer we were looking for. The next question I want you to answer is, what is the sales total by order date? The results should look something like this. Okay, go ahead and pause the video and try to answer this question. Alright, here's how I solved this problem. I said select order date, sum the quantity times price, from the orders table, interjoin to the order lines table on the order ID column, where the order status is completed, then I group the results by the order date. And if I run this query, we get the results we were looking for. Well, let me ask you this. What if we wanted to group the sales amount by month and year? How can we do that? Well, this is possible, but we're going to have to use a new function. In SQLite, there's a string format time function, strftime, which we can use to format dates in a custom way. So here's what I'll do. Instead of returning the order date, I'll call the strftime function, then I'll pass in a formatting pattern I wish to use for the date. In our case, I'll say, let's format the date by month-year, then I'll pass in the order date as the second parameter. Okay, so calling this function will transform a date like this into a format like this. Now there's only one more thing to do. We need to change the group by to be the formatted string. So I'll copy this expression and I'll paste it here. And running this query gives us the result we were looking for. Cool. Now you might be wondering, how did I know what to put here in the formatting parameters? Well, I don't have these memorized, so I did a quick Google for SQLite date functions, and I found this in the documentation that describes all the patterns you can use. My point here is, there's a lot to know about SQL, and you're not going to be able to learn every single SQL function and argument available to you. So you're going to have to refer to the docs, and/or you can use generative AI, like ChatGPT, to figure out how to get the exact results you're looking for. One more thing I want to point out is that most SQL you write can be used interchangeably on any of the popular relational databases, but there are some exceptions. In other words, each database has different functions available to them. For example, the string format time function we just used is particular to SQLite, and in Postgres and many of the other databases, you'd have to use different functions to achieve the same result. So be prepared to deal with minor deviations between the different databases. Okay, there's a few more things I want to cover before wrapping this video up. So as I said earlier in the video, the vast majority of the SQL you'll write are read operations. In other words, select statements. But you may need to do some other SQL operations, such as creating records, updating records, and deleting records, so I'll briefly cover these operations. Now, a quick word of warning. Using select statements is typically pretty safe to do, at least in terms of corrupting data, because select statements don't alter data, they just read data. But what I'm about to show you is some statements that can modify the data in your database, and if you're not a programmer that's confident in what you're doing, then you probably shouldn't be doing what I'm about to show you. So use this caution as a general rule of thumb, and it should keep you out of trouble. So here's what we're going to be doing in the next couple of minutes. We're going to add a new customer to the customers table, then we'll do an update on the customer, and finally we'll delete the new customer we just added. So how do you create a new row in a table? Well, you'll use the insert statement, and it will look something like this. Insert into the table you're interested in, then in parentheses you'll include a list of the columns you wish to populate, then you'll use the values keyword followed by a set of parentheses with the values you wish to insert. Now it's important to know that this first value will be inserted into the first column, and the second value will go into the second column, and so on. So knowing what I just showed you, I want you to go ahead and try an insert statement to add yourself as a customer to the customers table, but don't execute the query until you see my solution. Okay, go ahead and pause the video and give this a try. Okay, here's my insert statement. I said insert into the customers table, then I listed all the columns in the customer table, except for the customer ID. The reason I'm leaving off the customer ID is because it's automatically generated when a record is inserted. Next, I'll include the corresponding values here, and that's it. This is a valid insert statement. So I'll go ahead and run this, and you can run yours, and it was successful. And if we query the customers table, we see the new row I just inserted right here. The next thing I want you to do is update the customer record we just created. To do updates, you'll write a SQL statement that looks something like this. Update table, set column 1 equal to some value, and then if you have other columns to update, you'll add commas to separate each column you're updating. And lastly, you'll typically use a where clause to specify what row or rows you wish to update. So let me have you try this. Go ahead and write an update statement to change your customer name in some small way, but don't execute your update until you see my solution. Okay, go ahead and pause the video and write your update statement. Alright, here's my update statement. I'll say update customers, set name equal to my name that includes my middle initial. Okay, technically this is a valid update statement and I could run it if I wanted to, but is this going to do what I'm wanting it to do? Well, no. If I ran this query as is, it would update every customer name to be my name, which is obviously not good. So instead, what I'll do is I'll be more specific about what rows I want updated, and I'll do this by saying where the customer ID is 25. So as a general rule of thumb, you should almost always have a where clause when you're writing an update statement. Otherwise, you're probably going to accidentally update records you didn't intend on updating. So I'll go ahead and run this query, and as you can see, it seemed to work, and if I query the customers table again, I can see my updated record. The last operation I want to show you is delete operations. Here's the format you use when writing delete statements. You say delete from whatever table you're interested in, where some criteria is true. So go ahead and write a delete statement to delete the new customer record you just inserted, but don't run the query until you see what my query looks like. Go ahead and pause this video and try writing your delete statement. Okay, here's how I wrote the delete statement. Delete from customers table, and I could technically stop right here and I could execute this statement, but what do you think would happen if I did? Well, if I ran this statement as is, it would attempt to delete every customer in the customers table. Not good. So instead, I'll be a bit more specific about what I want to delete, and I'll add a where clause that says where the customer ID is 25. Now, as a rule of thumb, you should almost never run delete statements without having a where clause, so do keep that in mind. Okay, let me run this delete query, and it seemed to work, and if I query the customers again, I no longer see the record I inserted a few moments ago. Cool. Alright, hopefully this video has given you a nice quick start on SQL. If you found this video helpful, please consider liking and subscribing to the channel. Thanks for watching. Goodbye.